Hello, Algebra. I am about to get started, but I first want to show you, thanks to the inspiration of my students, although I'm blanking on which hour, I did invest in these fine pens. And so far I'm liking them, you know. It takes me a while to really kind of love a pen, but we're going to enjoy using these today, and I just am very intrigued to start off with that orange. So we're gonna start there, all right? All right. So lots of solving in this chapter. Lots of solving. So this is really checking to make sure you got it, okay? So we're going to follow the same procedure. If you just get in these good habits, draw your line for your balance, circle your variable. We want this alone, right? And it's this minus 12. So you have to think of undoing that, unpacking that. Opposite of subtracting 12 is adding 12. Negative 12, positive 12, 0. We are left with an x on this side, and 8 plus 12 is 20. We are done with that. Go to number 2. Draw your line. Again, the variable is on the right side. Well, not again. The variable this time is on the right side, but we are still going to look. We want this alone. Doesn't matter what side. And we're saying, okay, it's that plus 6. So again, we want to do the opposite. So we want to do the opposite of adding 6, and we want to subtract 6 on both sides. And when you subtract, you don't get to choose the order. You got to go straight down. So 33 minus 6. I'm going to borrow. And that is going to be a 27. I'm liking these colors. All right, number 3. When we look at number 3, it says write an equation to represent the relationship a number decreased by 9 is equal to 6, then solve. Okay, so I've got two things. I've got to write my equation, then I have to solve. So remember, when it says a number, that's just like any variable, x. So we're going to start with x. A number decreased by, that is subtraction. 9 is equal to, equal sign, 6. So I've done the first part. I wrote my equation, has an equal sign, if it's an equation. Then we're going to draw our line, locate our variable, and solve. And it is subtracting 9, so I'm going to do the opposite, which is adding 9. X is equal to 15. Okay, now we're going to switch. So these had to do with adding and subtracting, right, when we were solving. Then the next thing we did in the chapter was multiplying and dividing. So we're going to practice that for a little bit. We're going to circle the M. Now you have to look and say, what is happening between these? It's a multiplication. Even if there was a negative here, it's still a negative 8 times m. It's a multiplication, so you do the opposite of multiplying, which is dividing. And I think that's the easiest way to show it with that little fraction bar, which is also a division, because 8 over 8 is 1. So I'm left with the m alone, which is what I wanted, and 56 divided by 8 is 7. All right, then we're going to move on to the next one over here. Draw your line, locate your variable. But in this case, although it is, I do agree, multiplication still. I had talked to you about this special situation when you have a fraction. Because, yes, we would divide both sides by a fourth, 1 over 4 on both sides, but that you get a double-decker fraction, and that can be intimidating. So a better option is you can multiply by the reciprocal, because dividing by a fourth is the same as multiplying by 4. So we are going to do that on both sides, because now these all cancel off. Yay. And this is all then equal to the number 1. So I have x equals negative 6 times 4 is a negative 24. And we again get to practice writing an equation and solving it. So write an equation to represent the product. You got to know what those words mean. Product means multiplication of 6 and a. So 6a. when you write a number and a letter together, we know that is a multiplication between them, which is a product. Is equal 24. So I did the first part. Now I need to solve that. So I'm going to draw my line, locate my variable, look at what operation lies between my variable and the number, and that's multiplication. I will do the opposite and divide. 6 over 6 is 1, and I'm left with 1a. I'll just write a. 24 divided by 6 is 4. Now we get to multi-step solving. So we still want to draw our line, we still want to locate the variable, but the thing is, in this case, we've got all sorts of stuff going on. Let's get rid of these parentheses first. If it was just, well, I'm not going to say it. We're going to use distributive property and multiply 3 times p, which is 3p. 3 times a negative 5 is a negative 15. Remember, subtracting 15 is the same as adding a negative 15. So you'll see me use those terms interchangeably. I'm just rewriting the rest to be super clear. Now I have 1, 2, 3 terms over here. We look for like terms. These are like terms. Don't forget the signs. We got a negative 15 and a positive 8. So 3p stays, and when I combine those two, I get a negative 7. Rewrite the rest. Now we do the opposite of PEMDAS. So we do SADMEP, as we call it, and subtraction addition first. You have to first get rid of the parentheses before you apply that, and we did. So we're going to add 7 to both sides to do my adding and subtracting first. I'm left with a 3p on this side equals 24. Now I can do the multiplying and dividing. So I'm going to divide by 3, left with the p equals 8. Okay, let's go over here to number 8. Draw your line, locate your variable. All right. So we have a c and we are dividing it by 3 and we're subtracting 2. So when we look over here, there's no parentheses, so they're all gone, and that's good. And this minus 2 is separate. If the minus 2 is up attached on top here, that would kind of be stuck together, but it's not. So we can get rid of, we can do our adding and subtracting first in this case, like we're supposed to, because that 2 is free to go. So 17 equals c over 3. Then again, you say, what happens here? It's c divided by 3. So the opposite of dividing by a 3 is multiplying by a 3 on both sides. Then we have to do 17 times 3. So we can go off to the side here and do a little multiplication and get 51. All right, fantastic. Wow, all different colors. That was really fun. Page, whoops, is that right? Oh, the back of it. Okay, there's 3 sides. Oh, that's not, okay. Here we go. All right, a painting company charges $250 base plus 16 per hour. Another painting company charges $210 base plus 18 per hour. How long is a job in which the two companies are the same? And another word for same is equal. So we've got 2 different companies. So let's just take a look at this first company. I'm going to do this one in pink. Company charges $250 base plus 16 per hour. So base means you pay that for sure. So if this painting company comes to you, you're going to pay $250 no matter what. Plus you're going to add an additional charge of $16 for every hour they're there. So the thing that's changing is we don't know how many hours are there, right? So we're going to put that as our variable, x, or whatever, h, whatever you want to put for a variable, okay? Now we're going to take the blue and go to the other side. It says another painting company. Oopsie, sorry about that. Okay, another painting company charges $210 base plus 18 per hour. So again, you're going to for sure pay the $210, but they're a little more expensive per hour. They're 18 per hour. So again, we're looking to see when are they equal. So we need to solve this. Okay, so we're going to draw the line. And if you notice, we won't circle the variable because we have it on both sides. So until we get these together, we're not gonna circle that. But these are together. This is a term. This is 16x and this is 18x. So when we move this, we don't just move this part, we move the whole term. So I'm going to subtract, because it was a plus here, 16x, and subtract 16x. I'm left with the 250 equals 210 plus 18x minus 16x leaves me with 2x. So I got the x's together. Now I can continue solving. So I'm going to circle this. I got the 2 multiplied by it, and I got the 210 added. So the opposite of SADMEP, or PEMDAS, is SADMEP, which is add, subtract first. So we subtract these, we get 40 equals 2x. And then divide by 2, and we have x equals 20. Question is 20 what? When is it the same price? 20 what? What did x mean? X was the number of hours. So in 20 hours, it'll be exactly the same. All right, then we get to some more complicated problems here. And I'm just going to pen with some more colors here. Let's try that orange again. So, oh, and then we're going to have a little commercial break. All right, so we're going to draw our line. Again, we have a situation where we have a variable on both sides. You want to look at that instead of these. Look at these first. We got a positive 4a, and I know it's positive because of this. Got a positive 7a because I know it's positive because of this. This negative goes with the 17. So I want to move the smaller one, so I'm going to subtract the 4a on both sides. 3a minus 17 equals 1. I'm going to circle the variable. We're going to add the 17 to both sides because we do add, subtract first. And now we're going to divide because it's multiplication there. We get 6. Next, we're going to draw our line. And remember I said get rid of the parentheses first. So we have to do some distributive property or spider legs. So 3 times 2x is 6x. 3 times a negative 1 is a negative 3 plus 5 equals, do it again, 6x. And it's plus this time, 6. Always look what's before this number too. If there was a negative here, you would have to multiply both by a negative. Same thing over here. You always look what's right before it. So let's combine like terms because I see 2 whole numbers here. Or not whole, one's 2 integers here. So we have 6x and we have a negative 3 plus 5. So it's plus 2 equals 6x plus 6. So I've got the same thing on both sides. And so I'm going to subtract, not the same thing, but I have the variable, and look what happens here. My variables cancel out on both sides because I had a 6x on both sides. So now I'm left with 2 equals 6. Class, is 2 equal to 6? Absolutely not. That is a false statement. So when we get a false statement when we're solving an equation, what do we write for our solution? Because remember, we're looking to solve this for an answer that you can fit in here and it will work. Over here I could fit in a 6 in here and I'm going to get the same number on both sides. What's my number here? And the answer is none. No solutions. That's the answer. That's not the answer. False is not an answer, nor is 2 equals 6. The answer is nothing, no solutions. Alrighty. Now we're going to get into solving when we have multiple variables. We got q, x, and p. So the question you always have to look for is what are you solving for? And it says it right there for x. So make sure you circle that x because otherwise you're going to kind of lose track of what you're trying to get alone. So here we're trying to get the x alone, so I got to get rid of the p and then I'm done. Well, it's the same as everything else, it's just letters. So it's x divided by p. So what's the opposite of dividing by p? Multiplying by p. So I'm going to multiply. This is now on the top. So this p and this p cancel. Gives you 1. I'm left with the x now. Equals p times q. And you can just write that without the dot and write pq. And you're done with that. All right, we have another one to practice right here. We have it, and it says solving for y. So we're going to draw our line. We're going to circle the y so we stay focused on that. Now, we don't want to start just getting rid of this right away. We want to do the opposite of adding and subtracting. So what's being added or subtracted? The 3x. So we got to move that whole term first to the other side. Now notice I just wrote it down here. You may be already wondering what you're going to do with that, but let's just stick with this for now. This will cross off and give you nothing, which is what we want. This is a positive 7y, so I can just write 7y. And now remember I said write this just in the order you see it. So 2 minus 3x. Now we need to solve and get our y still. It's still not alone. And it's 7 times y, so we're going to divide both sides, the whole thing, by 7. I get a 1y, and I get this crazy looking thing for the answer. Okay? So if I ever know, if I tell you what x is, I can just pop it in and I'll know then what y is. Depends on itself. There. All right, here we jump into a new arena. These are called what class? I'm trying to get this straight. These are both a fraction equaling a fraction with an equal sign. Right? Sometimes up here we've had fractions. Where are they? Where are my fractions? Oh, right here. I had x over p times p over 1. And then we had multiplication there. So we can cross cancel. This is not multiplication. This is an equality. So we have a proportion. Fraction equals fraction. And we do over here too. Fraction equals fraction. When it's one fraction equal another fraction, we have what's called a proportion. So I am going to now use my cross multiplication skills. Some of you, when it's just numbers, you know this already, that you can do 3 times 4, which is 12, divided by 2, which is 6. But we're going to do a b times 2, just to show you this, is equal to 3 times 4. Those parts of the x are equal to each other. So I have 2b equals 12. Draw your line, locate your variable, and you can solve this. Whoops, sorry. I'm really packed in at the desk I'm working at here. There's no room. So you could, cross multiply and divide. That's no problem. But the reason I want to show you this is because that you have to use over here. So the same process is what we're doing right here. So this doesn't just have number here. It has x minus 4. And then you have the x over here. So we have to do more solving in this one than that. So let's start our cross multiplication. So it's 30 times x. And then again, you bring down the equal. And now we're going to multiply this. 2 times x minus 4. Remember, I put this in parentheses. They're stuck together until I unstick them, which is by distributing through. So I have 30x equals spider legs, 2x, and then minus 2 times 4 is 8. So I did multiply that 2 by both things up there and got the 2x minus 8. Now draw your line, and we can see we have an x on both sides. I got to move that whole term. So I got a 30x and a 2x. I'm going to move the smallest term. That'll keep away the negatives because there tends to be more errors there. 30x minus 2x is 28x equals, I have a negative 8 left here. Don't lose your signs. Be very careful. I'm going to divide both sides now by 28. And I'm left with x equals negative 8 over 28, but I see they're both even, so I know for sure I can drop down at least once. But actually, we can divide by more than 2, can't we? What can we divide by? We can divide by 4. So if I divide the top and bottom by 4, I'm going to get a negative 2 over 7. And that is how you leave it. You don't divide that out. You can just leave it as a fraction. All right. Now we get to the similarity problems. So half the battle here is drawing the right picture. So a flagpole. So as soon as I see a flagpole, I'm going to just draw myself a little flagpole. Casts a shadow. So shadows are always on the ground. So make a shadow coming out from your flagpole. That is 75 feet long. Okay, so make sure you don't label the flagpole 75. It's the shadow that is 75 feet. At the same time, a 6 foot tall, I should put 6 foot tall Mrs. Silva my little ponytail, my eyes, my smile. There. 6 foot tall Mrs. Silva. Actually, I want to put it on this side. Casts a shadow that is 9 feet long. So again, the shadow's on the ground and it's 9 feet. Write and solve a proportion. Okay, so a proportion, we just talked about that right here. Proportion is a fraction equaling a fraction. So you can set that up. It's a fraction equaling a fraction. Remember I said, first of all, you've got to put your variable in, and we didn't even write our variable here yet, did we? Write and solve a proportion to find. What are we trying to find? The height of the flagpole. So that is our variable, x. So put in your x first, and then you're going to go over here, and what else do we know the height of? We want to find the height of the flagpole, and we're given the height of me, 6 feet. Now I'm going to go back to the flagpole and do the shadow. Shadow is 75. And then I'm going to go back to me, and what's my shadow? 9. Could you have done it like this? Just for those of you that maybe did this, x over 75 equals 6 over 9. The answer is yes. So there's a couple ways you could set it up. This is primarily the way I taught you, though. So you would then need to do 75 times 6. So let's do that. That's 450. So x is equal to 450 divided by 9. Well, that works out well, doesn't it? Because 9 goes into 45 5 times, and then it's another 0, so it's 50 feet. Okay, and we will now do these triangles. And remember, the triangles are written in order. So if you're not sure which side goes with what over on this side, this one's set up kind of nice, but sometimes they're turned and it's hard to tell. So use this to tell. So again, whenever you have similarity like that, you're going to set up a proportion. So get your fraction bars ready. Those are my fraction bars. And I'm going to put my x on my top of my fraction. Now we're going to take and go to this side. What's in that same place? SU. SU is the same as MP. Yep, 14. It is laid out exactly right, the way it looks. Then I go back to the figure with the x, and I see that there's a 4. Then I go and say, what's similar to 4? The 6. Again, if you had x over 4, you could have had equal to 14 over 6. But this is primarily how I've taught it. So you're going to cross multiply and divide. So you do the 14 times 4, 56. So x is 56 divided by the 6. Okay, so then let's divide that. 6 into 56 is 954, and you get 2 over 3, 9 2/3. Why did I say 2/3? That doesn't make sense. There's a 6 here. 2/6, which reduced to 9 1/3. But You can also do that, like how many sets of 6 are in 56. And you would figure out 9 and you say, okay, that's 54. How many are left over? 2 out of the 6, which is a third. So we've talked about a couple ways to do that, but here is the answer. Oh, I need my unit, centimeters. I'm running out of room here. All right, we're on our last page. I think that's a great moment for a commercial break. I today am going to be enjoying a beautiful can of Zevia Zero Sugar tea. My favorite is passion fruit. It is a sweetened hibiscus tea, naturally flavored, of course, caffeine free, folks, because it is 9:37 at night and Mrs. Silva does need her beauty rest as much as possible, so she needs to be able to fall asleep after we're done with this lovely video. As you can see, there are wonderful organic brewed herbal teas in there, purified water, organic stevia leaf extract, many good things. So one moment, please. Feel free to grab a drink yourself. That is good stuff. What a treat. I was saving that just so I could enjoy it. Okay, now last page. We jump into some tougher things here, don't we? We jump into absolute values, and we've talked about how absolute values are the distance from 0. So they're always a positive number. In other words, the absolute value of anything can never be equal to a negative. If it ever is, then it's just, there's no solution. It can't be. So, but now to get to the answer, there's certainly answers to this, because there's actually 2 answers I could put in there that would equal 12. And that is, when you have your absolute value, it is x equals 12 and x equals negative 12. We didn't have any solving to do there. And it is true, absolute value of 12 is 12, and absolute value of negative 12 makes it positive, and it is 12. Okay, when we get to number 19, it's a little different because there's something inside here other than the x. The good news is there's nothing on the outside, because if there was anything on the outside being added or multiplied, I'd have to get rid of that first, but there's not, so I can split this up into 2. Remember, the first one looks just like this without the absolute value. And the second one looks just like this, except instead of positive 12, we're going to do a negative 12. So I set it up first, and then now I'm going to solve each of them. So draw your line, locate your variable, and we're going to subtract 3. X is equal to 9. Draw your line, locate your variable. We're going to subtract 3, but watch what happens. X is equal to negative 15. They don't look anything alike. So like don't think you get one and you just do the opposite. That only works when it's just an x alone. I have 2 distinct answers, both of which, negative 15 plus 3 is a negative 12. Take the absolute value, you get 12. 9 plus 3 is 12. Absolute value, I get 12. They both work. They're both full-fledged answers, and they're both worth 1 point on the test. All right, so Jane can braid 60 inches of rope in 1 hour. What is her speed in feet per hour? Okay, so we have 60 inches, and we know that for every 12 inches, we get 1 foot, correct? All right, so I'm going to have to take that 60 inches and divide it by the 12 to see how many feet, and that is equal to 5 feet. Okay, and that's it, I guess. We have the hour, and they wanted it in hours, so I don't have to do anything with the hour. So we'll just say 5 feet per 1 hour. Let's see. The ratio of boys to girls in Mrs. Silva's algebra class is 6 to 2. So remember, when I say a ratio, that is the same as saying a fraction. So 6 to 2 can be written as 6 to 2. Now, there are 5 girls in the class. How many boys are in the class? So you can set up a proportion for this. Okay, so we put what on the top? It said ratio of boys to girls. So that means this was my boys, and this represented my girls. That was the ratio. So I'm going to set up a proportion here with this 6 over 2, because now it says there's 5 girls. So the girls are in the bottom, so I'm going to put the 5 in the bottom. How many boys? So the boys is what I'm trying to find, and that's going to be an x. So we can cross multiply and divide. So 6 times 5 is 30, divided by 2 is 15 boys. When we get to this, let me get my calculator out. You're able to use your calculator for these. So we are going to take this and make it into an equation. So 40 is simply 40. Is means equal. 20%, you move the decimal 2 spots, and it's 0.20 or 0.2. Of is multiply, and what number is x? So I basically, if you want me to put this the way you're used to seeing it, that's what you have there. Now we're going to draw our line, locate our variable, and it is 0.2 times that. So I'm going to divide by 0.2. I'm going to grab my calculator and do 40 divided by 0.2, and it's 200. All right, what is 30% of 45? So what, x, is 30% of multiply 45. So again, I'm going to take this and do 45 times 0.3, 13.5. All right, we're almost there, folks. We're on the home stretch. A sales clerk earns 4% commission on each sale. What is the commission earned on a sale of $54.50? Okay, so they don't tell you her base salary, right? Because the base salary is the amount of money she for sure makes no matter how much she sells. And some companies may not give you any. Maybe your total salary is based on sales. So it really depends. But in this case, either way, I think it's a sales clerk. So most sales clerks get something. So we need to look and say 4% of commission on this whatever she sold. And it says she sold $54.50. So we have to change that to a decimal, and don't forget to go both 2 spots, not just one. So it's 0.04 times the 54.50. 0.04 times 54.50. That's $218. So on that sale, she sold over $5,000 for something. She gets $218 from that sale. So it motivates, you know, salespeople to want to sell, right? That's their job. I would be terrible at it, but anyway. The check for breakfast is $28.93. What is the best estimate of a 20% tip? So remember, for tip, what was the mantra we came up with? Shift, round, double. There it is. So shift, so that means just shift the decimal over. So we have $2.89, right? It's going to look like that. So you're doing this in your head. You're shifting it. You're seeing 289. You're rounding it. That's about $3, right? I don't want to round to 290. I want to get it to a whole number. So that's pretty close to 3. And then double it. So I rounded it in my head and got 3. And then I doubled it and got 6. So you just write 6. So you do that in your head. You're like, shift, okay, 2.89, that's about 3, double it, 6. Find the percent increase. Okay, whenever you're looking for a percent increase, you are going to subtract the 2 values they give you. So I actually just did this tonight. What did I do this for? Just one moment, please. What did I do that for? I was subtracting. I know, we were finding out the percent that our medical insurance went up. And so my husband told me what he spent monthly before, and then what he spent now. And so with the new insurance coming out for his company, so we subtracted the 2 values and then divided by the original one, the one he originally had, not the new one. And we got the percent increase. And I'm here to tell you it was 14%. And that is a lot. But anyway. So we're going to subtract 49 minus 18 over the original one. So the 18 is the original one. So 49 minus 18 equals 31. And then divide by the 18. And it's 1.72. So we are going to shift the decimal because this is not in percent yet. So either shift it 2 spots to the right or multiply by 100. And it's 172%. And it makes sense because it would be double. The 100% would be up at 36, you know, but it's way past that. So yeah, it makes sense. What is the result when 60 is increased by 20%? What do I think? I think my favorite color might be this green, or it might be the yellow. I'm not really sure. When 60 is increased by, that means we're going to add something to it, but we don't add 20%. That doesn't make sense. We're not going to add a percent to 60. We got to find out what the percent of 60 is. So we need to go down here and do 60 times 0.2. That is 12. That is the value that you're going to increase it by. So you have to go off and do it. 60 is increased by 20% of that. 20% of that. So my answer is 72. All right, 2 more. The owner of a shop bought a shirt at the wholesale. Remember what wholesale is? That's a cheap, cheap, cheap price. So bought a shirt at the wholesale price of $7, marked it up 400%. What's the selling price? So they had, what's the selling price? So that for sure they're gonna pay the $7 plus whatever the markup is. And then we're gonna get the total. So to get the markup amount, you need to take the 400%, shift the decimal 2 spots, so we get 4 times the 7. That's $28. They raised it. Wow, that's a lot. So they sold it for $35. Probably not uncommon though, to be honest, because hats probably aren't that expensive, but they can be when you buy them in the store. So they probably do get marked up that much. All right, the grand finale. I will use my yellow. John bought a TV for $145. He received a 15% employee discount, so that means it went down. How much did she save? So they didn't say what was the original price. They just want to know okay, sorry, I was just thinking. So the TV was $145. He went up to the cash register and got the 15% off. And they want to know what he got off from that. So I take my original price and I'm going to multiply it by the discount, which is 0.15. $21.75. That is how much they saved. So if I asked you, though, how much did he end up paying, right, there'd be another part to that. You would take the 145 minus the 21.75. And that is 123.25. But they didn't necessarily ask it. They just said, how much did she save? So that's 21.75. All right, you guys, hopefully we're following along, doing great, practicing the ones that you need help with, hopefully for sure. And let me just look at the test here. I got it right here. I want to make sure I didn't miss anything. Nope. Nope. That's all she wrote. Have a good night. Bye.